Good afternoon. This is Mrs. Boland with the University of West Florida, working on our Elements of Statistics class, doing discrete random variables. We have a problem here, and it says use the following information to answer the exercises. A physics professor wants to know what percentage of physics majors will spend the next several years doing postgraduate research. He has the following probability distribution. We make sure everybody knows that this is a probability distribution table right here. You must complete and identify all the options that X can assume, and then the associated probability with each of those X. That is called a probability distribution table. Make sure you know how to create those. All right, it says define the random variable X. And we have three options, and our answer is the first option, which says X is the number of years a physics major will spend doing postgraduate research. So they will either do 1 year, 2 year, 3 year, 4 year, 5 year, or 6 years doing postgraduate research. The next question says define the probability of X or the probability or P of X or the probability of X. P of X is obviously the probability of X. And we have a couple of options, and our answer is the middle option right here, which is the probability of X is equal to the probability that a physics major will do a postgraduate research study for X number of years. Remember, X can assume the values of 1, 2, 3, 4, 5, or 6 exactly. The next question is find the probability that the physics major will do postgraduate research for 4 years. So to solve that, we come up and we look at we identify X, and X is going to be equal to 4. And we say, well, we want to know what is the probability that the physics major will do postgraduate research for 4 years. So we identify X equals 4. Then we look at the probability of X associated with 4 years, and that answer is 0.14. So we will put 0.14 right there and check our work, and we got the first three, including the one we just answered, correct. Okay, so the next question says find the probability that a physics major will do postgraduate research for at most 3 years. So the number or the phrase at most 3 years, that means it could equal 3. 3 is okay. At most, we cannot be greater than 3. So that means we're going to be looking at X equals 1 plus X equals 2 plus X equals 3. So those are the three events that we're going to identify, and we want to know the probability that any one of those three events will occur, okay? So that's the sum of those numbers. So it's 0.2 plus 0.2 plus 0.18. So that's going to be 0.58, okay? Because 0.2 plus 0.2 is 0.4 plus 0.18 is 0.58. So we'll put in 0.58, and we will check answers, and there we go. So we have that taken care of. So here we go. We're going to copy this because we're going to need this information for the next screen. It says, on average, how many years would you expect a physics major to spend doing postgraduate research? So this is how we solve this. Okay, so we'll paste our table in and hope it pastes better than the last one. Oops, let's not do that option. Let's do this option, see if that's better. Nope. Let's try our third option. There we go. So the question again, going back to our question, says, so on average, how many years would you expect a physics major to spend doing postgraduate research? Alrighty, so how many years would you expect? The key word is this word expect. Remember, when we talk about the average number of years somebody's doing something, we can say, what is the expected value? What is the average number, or what is the mean? All of those words, expect or expected, mean, and average, all have the same meaning. It means we want to know the average of what's occurring. So we want to know what the expected value is, and that is equal to, oops, let me see here. So the expected value is the same thing as average, which is the same thing as the mean, okay? So our formula for the expected value, okay, so mu is going to be equal to the summation of x times p of x. So that means we are literally going to be taking, let me switch pins here. Let's see if I can get that to be over here. So that means we're going to be taking, oops, we missed our probability of x. We'll write that in just a second. So that means we're going to take 1 times the probability of 1 occurring and add to that 2 times the probability of 2 occurring, add to that 3 times the probability of 3 occurring, add to that 4 times the probability of 4 occurring, add to that sum, continue to add, that's going to be 5 times the probability of 5 occurring, add to that 6 and the probability of 6 occurring, and then I'm assuming there's a 7 there. We're going to have to go back and look at our data, and the probability of 7 occurring. So let's go ahead and go back to our other screen real quick and see if we can really grab, oh, there's not a 7. And our other probability that we were missing is 0.2. So let's go back and see if we can grab all of that information and get that copied down properly over here. We'll do our third paste. Well, it's still not copying. Oh, that's what it is. It's a shift issue. So let's see if we can shift this over. Let's go that way and then put there. So that's how that's supposed to be done. So we'll delete this whole thing right here if we can. Let's see, can we delete that? We sure can. Look at that. Well, we can delete most of it. Let's see if we can get the rest of it. Alrighty, there we go. Alrighty, so back to our formula over here. So this is going to be equal to 1 times 0.2 plus 2 times 0.2 plus 3 times 0.18 plus 4 times 0.14 plus 5 times 0.07 plus 6 times 0.21. Okay? So let's go ahead and add in one more middle step to make sure everybody gets it. So 1 times 0.2 is just going to be 0.2. And then we go 2 times 0.2, and that is 0.4. We're going to add to that 3 times 0.18, and that is 0.54, plus 4 times 0.14, and that is equal to 0.56. We're going to add to that 5 times 0.07, and that is equal to 0.35. And the last one is going to be 6 times 0.21. Oops, I multiplied something wrong. 6 times 0.21, and that is equal to 1.26. So now we're going to add all those together. So let me shift this up just a little bit. And so that is going to be equal to 0.2 plus 0.4 plus 0.54 plus 0.56 plus 0.3, oops, not 35. Shoot, I've got the calculator. I got to start all over. So that's 0.2 plus 0.4 plus 0.54 plus 0.56 plus 0.35 plus 1.26, and that is equal to 3.31 years. So as a physics major, if you're going to go into postgraduate research, you can expect the expected number of years of being in doing postgraduate research is 3.31 years. So let's go back and enter that in, 3.31, and we'll check our answer. And there we have it. So that is how we solve that particular problem. Now, okay. If we wanted to take, if you have a calculator that is like a TI-84, you can enter this data in a little differently. And we can enter it in such as, let me pull this up on another screen real quick. Let me log in real quick. And I'm not gonna show this on this video. I want everybody to do this by hand. So we'll just go ahead and conclude the video at this point on this particular problem. If you have questions on doing your homework on this problem, send me a quick email and I will be happy to help you out further.